Hello, my name is Brentton White, and this is my DES304 Postmortem presentation. Movement is a crucial way of empowering the player. I can't remember where I heard this, but I've considered this quote whenever I found myself designing game mechanics. You feel empowered, even liberated, when you have flexibility of motion, whether it's jumping, hovering, flying, or any other kind of advanced movement technique. I settled on something that I suspected wouldn't be too advanced to program given my relative lack of experience with C languages, and that would allow me to practice balancing a mechanic based on both its feel and its utility. My initial intended design involved the creation of a block that was capable of multiple aerial maneuvers, bouncing, dashing, and jumping in creative ways to traverse a level. As will be seen, this objective was ultimately not realized due to my inexperience with Unity, although I did manage to implement several of the items I had originally envisioned during my initial design concept. I ended up deciding early in the project's life cycle on a need to allow relatively free rein in the player's movement options. However, as will be discussed in the development process section, my lack of experience in C proved far more detrimental than I had previously expected. My intent had been to empower the player's ability to traverse the level via multiple methods, such as mid-air dashing and several types of jumps, as can be seen in the early stages of the development blog. In addition, several aspects of the level itself would be designed to force the player to think on their feet and react swiftly to changing situations. That said, however, I needed to ensure the player had reason to think ahead and plan out their moves. This is enforced via the limitation of mid-air jumps and dashes. The player has a maximum of 3 mid-air jumps and dashes available to them once they've left the ground. The initial jump is free, but all subsequent maneuvers will cost one of these mid-air tokens. These tokens are rapidly recharged while the player is on the ground. Originally, the player only recharged while stationary, but I suspected most players would be similarly bored with waiting as I was during the tests, and it was quickly changed to also recharge while moving. I came up with the idea of a simple obstacle course that would need to be traversed in order to progress. Naturally, in a more fleshed-out game, there would be some kind of justifiable skin to the game in question, but for the time being, visual primitives served my purposes. Many tests were run, both on the components of the obstacle course as well as the boosted jump and dash mechanic that was ultimately created. Various tests on distance were performed, and several modifications were made to certain panels, such as the wall hang panels and the bounce panels, and other panel types that were dropped entirely, such as the sticky red panels that ended up becoming the straightforward game over area if touched. One panel I'm particularly proud of is the gravity panel, as it's surprisingly robust in its functionality, serving its purpose of forcing the player down from the air and allowing them to regain control of themselves should they be running wild. As the gravity panel also severely limits the player's jumping capabilities while they are currently over it, it also serves as a useful obstacle to get in the way. If I had to come up with my greatest weakness of my development process during this project, it would unquestionably be my stunning inability to resolve the implementation of basic movement for what may have well been over a month. Although there were other pressing matters that occupied my time, such as my team's Dare Academy trip to EGX in mid-October, this does not, in my eyes at least, excuse my lack of progress on something so simple. Had I not squandered such an extensive amount of time on the implementation of basic movement, having to rework it at least 4 times to my memory, I would likely have been able to make the feel of aerial maneuvers more robust. Even so, the ultimate objective was reached, as the player is fully capable of mid-air jumps, as well as rapid course correction, should they still have remaining boost tokens to make use of. However, despite these setbacks, once I'd figured out how Vector 3s worked in the Unity engine, modifying them to produce the intended mid-air directional changes was relatively straightforward and, as shown on screen, would probably only need small modifications to further perfect the mechanic. I will freely admit I am far more comfortable with the Unreal Engine than I am with Unity, and what likely would have taken me only a few days in Unreal to create took me well over a month to fabricate within Unity's C#. It is clear that should I end up being required to work in Unity in the future, I will need to brush up on my C# skills to a far greater degree than I did for this project, even if I wouldn't likely be serving as a primary programmer and instead would be taking up a design role for such a purpose. While I am ultimately satisfied with the creation of the mid-air maneuver mechanic, I have found that it lacks the punch that I had originally envisioned it would have. Given more time, I would undoubtedly work to ensure that punch is felt by the player every time they do a mid-air directional dash. As it stands now, there's a sort of soft tap feeling that tends to occur when the player's velocity is too strong in one direction. I would undoubtedly need to refine this system, perhaps by stopping the player mid-air entirely, although I did attempt this and the results were unsatisfactory, or by strongly increasing the force depending on which direction they are currently traveling, which is something that is likely beyond my current abilities. Right now, a boost while traveling in its opposite direction completely lacks the desired punch factor. On a second point, another element that greatly bothers me also linked to previous issues with movement fabrication, and this comes down to the non-rotating camera. It would seem that my desired multi-direction mid-air maze is likely to require a specific function relating to the player character, that of directional forces coming from the player's viewing direction. Which is to say, I would have very much loved to experiment with a directional camera controlled either by the player's right control stick on a controller or a mouse input, but given how much trouble I'd previously had with basic movement implementation, I swiftly dropped this idea when I started to meet additional resistance, given that my remaining time was swiftly drying up, and it was ultimately threatening to leave the mechanic and the project as a whole unfinished and non-functional. Optimally, however, a directional camera controlled by the player that would influence the direction from which the force acting on the player comes when they perform a mid-air dash would be my ideal control mechanism for this mechanic should it ever be fleshed out in the future. Unfortunately, I simply lack the necessary expertise to actually make such a mechanic exist within the Unity engine. Perhaps in a future project I can revisit this idea and actually give it the due it deserves. Thank you for taking the time to review my DES304 Postmortem presentation.